All right, so we're only going to look at the first two examples today on 4.2. But go ahead and do the review 1 through 3 and answer those questions. So we kind of talked about this just the day before yesterday. An equilateral triangle has how many congruent sides? So equilateral means all sides are equal. There's 3 sides to a triangle, so all 3 sides are equal. An equilateral triangle has acute or obtuse angles. They're all acute, and what do they all add up to? So it's 60, 60, 60, 180 degrees. I guess I lost that. Each angle is 60 degrees, right? Which of the 3 is your equilateral? That's a toughie. Which of the 3? Which one's an isosceles? The first one. I will tell you that all equilateral triangles are considered isosceles. They're a special isosceles triangle. It's just like all squares are rectangles. It's just a special rectangle. A square is a special rectangle that has 4 congruent sides. Well, an equilateral triangle is just a special isosceles triangle. It has at least 2 congruent sides, but it really has all 3. So the only definition for an isosceles triangle is that it must have at least 2 congruent sides. Well, the equilateral triangle matches that definition. So if I ever ask you, is an equilateral triangle an isosceles triangle, your answer should be yes. Now, if you call this an isosceles triangle, I would mark you wrong for that because its most specific name is an equilateral triangle. Its super most specific name is an equal angular equilateral triangle, but I won't make you write all that. Yeah, it's a lot of words. So today we're going to concentrate on the word isosceles. The related words are equilateral, not that an equilateral, in a sense, as I said, all equilaterals are isosceles, but scalenes are definitely not. These are just the different side lengths that you can have on a triangle. A triangle either has no sides congruent, which is what scalene is, or all sides congruent, or at least 2 sides congruent. So there's your definition of isosceles. Then I want you to put, based upon what I just talked about, put the letters of the triangles here in your ovals. So which triangles A, B, C, D, and E are equilateral, which are isosceles, and which are considered right? And you could have some that are in 2 categories. So right. The board. And you can't assume something that's not written there. Compare your answers with those around you. Are you ready? Do you agree or disagree? Anybody disagree? I might have missed something. You put C in which one? Isosceles. I have no information on the side lengths for C. So I can only go based upon the fact that I know that one of the angles is right, so I can only call it a right triangle. It appears to be a right scalene triangle, but again, I can't make an assumption that it's scalene without any more information. So you've kind of reached a realm of geometry where you can't make assumptions unless things are detailed out for you through markings and that kind of thing. Okay, so let's look at our new theorems, all related to isosceles triangles. So I would put each one of these on a flashcard. So your isosceles triangle theorem says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So you've got, here's the two sides that are congruent here, and by the way, you must know this diagram. I will ask you the parts of an isosceles triangle. These sides that are congruent on the isosceles triangle are always called legs. And the angle that those legs create are your vertex angle. The other two angles are your base angles, and they border on the left and the right side of the side that's called the base. So out of the three sides, you've got the two legs. The third side that is not equal to them is the base. Now, technically, if this were an equilateral triangle, the base would also be equal to the legs, but we're not going to go there. So notice that this angle is directly across from this side here. So that angle is directly across from that side there. How do I know that? Because that's the only side that doesn't touch that angle. Some of you are going to have trouble identifying the opposite side. So here's my angle. The two sides that create that angle cannot be the side opposite. It has to be the one side that's not even touching that angle. And so this angle is directly across from that side there. And so that's the side opposite. That's why those angles are congruent. So anytime you're told that you've got two sides in a triangle that are congruent, then, based upon this theorem, you can immediately conclude that the angles are congruent as well, or vice versa. So this is your converse of the isosceles triangle theorem. I typically only recall one of them. It depends on what you've been given. So this one says if two angles of a triangle are congruent, then the sides opposite of those angles are congruent. So if you're told that those angles are congruent, then your next statement is that the sides opposite those angles are congruent based upon that theorem. So this would be the reason you would give in your proof this whole theorem. Your statements would be you have some sort of statement or some sort of way to show that two angles were congruent in a triangle, and then your next statement would be the then part of that. The reason of the then part of the statement is this whole theorem. Same thing here. If I'm told or somehow have a way to prove that the sides of that isosceles triangle are congruent, then immediately I can conclude that those angles opposite are congruent. So they're really one and the same. So you're not really memorizing different ones. You are not allowed to use the names of those theorems as the reason in your proof. Now your textbook might do that, but you might do that in your. Then theorem 4.5 says if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So here's your isosceles triangle. These are the sides that are congruent. So this is your base, and this right here is your vertex angle. So I'll just call it VA. And what this is saying is if I have a line that bisects this, and it creates a congruent angle here and a congruent angle here. In addition to that, this becomes a perpendicular bisector. So this is a right angle here, and these two pieces here are equal as well. So a lot of things happen with this line coming from the vertex angle and bisecting that angle. We get a perpendicular bisector. Two things we can conclude from a perpendicular bisector. We've got two congruent segments, and with perpendicular lines we have right angles, and right angles are congruent. So that's a way for us to be able to prove certain angles are congruent. Now, if you're told that this isn't a perpendicular bisector, then you can also conclude that if this is bisecting the angle that's created by those equal sides, then you can conclude that those angles are congruent. That would be the converse of this. So it just depends on what you're given, whether you write it one way versus the other. So look at question 5. If PQ is congruent to RQ, so we have to make up a picture. So let's name the picture we just made up. So let's call this P, let's call this Q, and let's call this R. So if PQ is congruent to QR in triangle PQR, then what angles are congruent? What angle is opposite PQ? R. So go directly from that side to the one angle that's not touching that side, and it has to be angle R. So angle R is congruent to what angle is across from QR? P. That's your conclusion. If this is true, then that is true. Underline the correct theorem number. Well, I don't have to memorize theorem numbers. I'd be writing the theorem, but we'll go with what we have above. What's being illustrated here? You have a line that is cutting that angle into two equal pieces. Is it 3, 4, or 5? Oh, if this occurs, then this occurs. So look, sorry, I missed the if under that part. So we're going from this original piece here to this original piece here. What's the difference in notation? What's the only notation that's been added? So we still have that angle and that angle congruent here and here. We still have the sides congruent here and here. So we know it's an isosceles triangle. We know that that's a vertex angle that has been bisected. What's the new thing over here? What's the new markings? Don't you have double tick marks here and a right angle marker here? So aren't they saying that if a line bisects the vertex angle of an isosceles triangle, there's the line bisecting the vertex angle of the isosceles triangle, then our conclusion is that we have a perpendicular bisector that's showing that this line is perpendicular and it's bisecting the segment that it's perpendicular to. So that would be 4-1. So let's look at problem 1. Is angle WBS. So this is kind of a weird picture. So some of you who don't like lots of stuff in the pictures may want to redraw some things. So some of you will see it immediately, some of you are going to have a little bit of trouble. So we've got a little triangle here, VWS, and we have a bigger triangle here. We have another smaller triangle here as well on the left. But notice that we have single tick marks here. So we have this teeny tiny isosceles triangle within this bigger triangle. And doesn't the big triangle and this teeny weeny triangle, don't they share the angle S? Right? So their angle S are the same anyways, whatever they might be. Anyway, so it goes on to say the angle V or WVS, so from W to V to S is congruent. So we put a congruence marker there, an arc marker. Is congruent to angle S. So then we need to mark angle S. Is segment TR congruent to segment TS? So is segment TR congruent to TS? Well, I'm going based upon the markings that they have in the picture. Number one, the fact that they marked these congruent, they didn't have to tell me that angle S and angle WBS were congruent. Okay? Because if this is an isosceles triangle, then the angles opposite those sides are also congruent. So I could have come to that conclusion on my own. So the question says, is WBS congruent to S? Well, yes. The explanation is your theorem from above. If two sides in an isosceles, there's SOS in the word isosceles, triangle are congruent, then the angles opposite those sides are also congruent. Then the question is angle R congruent to angle S? Well, they've already marked in the picture that R is congruent to S. So my explanation would be that right there. We don't have any other information other than what they've marked in the picture. Oh, and the markings show, we forgot that. The markings show that WV is congruent to segment WS. And also, we know that the markings show that angle R is congruent to angle WBS. So let's just kind of do this out on the side. If angle WBS is congruent to angle S, which we just proved that right here. So if this is true, then, and it's early in the morning. And we also know from the picture that angle, and I'm going to start, we'll write it this way, that angle R is congruent to angle WBS just by the markings in the picture. What can you conclude? What do you notice about these two statements? If they're congruent to the same thing, what do you know about these two? They're congruent. So then angle R is congruent to angle S. Did I use the transitive property or the substitution property? I actually used substitution. Could I have written it so that I could have used the transitive property? Yeah, the transitive property, what you end up with here, you have to start with here. So my answer would be yes. By substitution. C, reasoning. Right. So our reasoning there in pink is how we came up with that. So then the question is TR congruent to TS? Well, look at the whole entire triangle. Don't you have two angles that are congruent in a triangle? What's your conclusion if two angles are congruent in a triangle? Then the sides opposite those angles are congruent. So our answer to this one is yes. Yes. If two angles are congruent in a triangle, then these sides opposite those angles are also congruent. Here's a kind of complicated picture, and all they had to do was give us one congruency statement. And that was it. And really the markings that they had in the picture. I guess they gave us two, technically. They gave us these two. Okay, so flip it. Look at problem 2, and then we'll be done for today. So suppose the measure of angle A is 27 degrees. What do you think I should do with that? I'd mark it in here. So inside, because it's an angle measurement, that's 27 degrees. What is the value of x? So I'm not going to go through all of the rigmarole. Let's just talk our way through it. You can walk your way through it here if you want to, but let's just look at the picture. I'm going to turn my picture so it looks normal to us. Look what they've marked in the picture. This side is congruent to this side. So what is our conclusion that if these two sides are equal, what do I want? Angle A and angle C are congruent, right? So angle A is congruent to angle C. So that's number 1. That means that 27 degrees is also there. And the question is, what's the value of x? Well, x is right here. Alrighty. Can't I find the value of, I'm trying to see the picture. Is there one arc mark there or two? Oh, there's two, aren't there? So if there's two arc marks here, what is our conclusion about dB? If dB is bisecting, isn't that the vertex angle? Because those are the legs. So if dB bisects that vertex angle, what do we conclude about dB? It's a perpendicular bisector. So isn't this a right angle here? And isn't this piece congruent to this piece here? So then part 2 is that BD is bisected. Well, how is that helpful to finding x? Yeah, because there's two angles in that triangle. So if you look at just this part of the triangle right here, just that half, what do you know about these three angles here? They all add up 180 degrees. So then step 3, we're going to take 90 degrees plus 27 degrees plus x degrees should add up to 180 degrees. So 27 and 90 add to give you 117 degrees. And then we're going to subtract 117 from both sides. And so x degrees is equal to what? So you're going to have some problems with that now involve all those three theorems that we just went through. So if you see two angles inside of a triangle that are congruent, you immediately conclude the sides opposite them are congruent. That also tells you what are the legs of the triangle. It tells you what the vertex angle is. If that vertex angle is bisected, you know that the line bisecting it is a perpendicular bisector, creating right angles and two congruent segments on the base. Vice versa is true. If you have those two congruent sides, you can conclude the angles are congruent. So sometimes the answer is going to be much simpler than you think it is. So today your assignment is only 7 through 11 odd, which are not very many, and then 37 through, I can't read that far. Okay, and that's not that many either. You ought to be able to get that done before you leave today. So let's go ahead and start on that, and then I can answer questions.